We're told that a large water container develops a crack at its base and then water starts to leak out. The rate that the water is leaking out for the first 12 hours after the crack is a decreasing function, and several values of the rate are given in this table. The first thing we're asked to do is to find a Riemann sum with 4 subintervals, a right Riemann sum, to estimate the amount of water that leaked out of the container during the first 12 hours. How would we do that? Well, we're told to use a right Riemann sum. And so what that tells us is that we're going to use these values here, but we're going to focus on the height on the right. And I'm going to draw a visual explanation as to what this looks like. We're told this function is decreasing, which is cool. And so I can draw these 5 points. At time t equals 0, we're at 11. So that's at 0. At 2, 5, 7, let me extend this a little more, 12. We have our heights 11, and then 7.4 will be about there. 4.0 might be around here. 2.7 might be here, and then 12 will be there. So I don't know what's happening in the middle. We know that it's decreasing, but those are our graphs. I can try to pretend like I know what this line looks like. I'll draw that in red. Maybe it looks something like... That looks linear, but we know it's not perfect. So we're told to do a right Riemann sum. And I'll do this in yellow. So we're going to focus on those heights. So there we go. There's my first rectangle. My second rectangle. My third rectangle. And my final rectangle. Remember, a right Riemann sum, the height is determined by the value on the right. And the width is determined by the change in our time. And so, and I can talk about this in blue now. Here, I see that our width will be 2, and our height is 7.4. Now for the next one, our height is 4, and our width is 3. And so, this will be 7.4 times 2. This one is going to be 4.0 times 3. This one has a height of 2.7 and a width of 2. And so we can say that this will be 2.7 times 2. And this final one has a height of 1 and a width of 5. So this will be 1.0 times 5. Now, we use addition to add up these different areas, and I'm going to use my calculator to help me figure... Actually, I don't need my calculator to figure out these values. 7.4 times 2 is going to be 14.8. 4.0 plus times 3 is 12. 2.7 times 2 is 5.4. And 1.0 times 5 is 5. So we'll add these together. 14.8 plus 12 will give us 26.8. I'll write that down. 26.8 plus 5 plus 5.4 is 10.4. And these two added together will give us 37.2. And so we're told that the amount of water that's leaked out in the first 12 hours, in order to write this in our proper units, we can say that the amount of water is 37.2 liters. All right. And now, is this an overestimate or an underestimate? You might already be able to tell. But here, when we found our areas, because this was a decreasing function, all of our rectangles ended up being underneath when we found this right Riemann sum. And so, when we're asked if it's an overestimate or an underestimate, we can say, this is an underestimate. This is an underestimate. Because this is a, what type of sum is it? It's a right Riemann sum. A right Riemann, actually Riemann is capitalized, Riemann sum on a, and what type of function is this? It's a decreasing function. On a decreasing function. And so we see that it is probably a little more than 37.2 liters, and we have an underestimate because this is a right Riemann sum on a decreasing function.